I'm Pragya Srivastava, EC Department, AKGEC Ghaziabad. I'm here to record a lecture on control system. The course code is KAC 602. And we have started, as you all know, Unit 3. And we have started discussing time response analysis. And previously in my lecture in Unit 3, we have studied what are the different type of standard test signals which we can give to any system. And then we have studied what is time response. When a system is studied for its response in time domain, as and when the time varies, that is called time response. So variations of time is studied for response is called time response analysis. Now, coming on to first order system, that is shown in this picture. Previously, we have studied this system in my last lecture, and there we have studied that how the first order system, how the open loop transfer function having a gain of 1 upon st is connected to a negative feedback, unity gain negative feedback system. And then we have a transfer function by this expression. And then considering the same for output, we multiply rs here, then ct is equals to 1 upon st plus 1 into rs. So this is in s domain. Now we can find out the same in t domain. Now, what are we? So first of all, before finding it in time domain, let us study the kinds of inputs which we can give. So the kinds of input which we are giving to the system is RS will be 4, 1 will be impulse, second will be step, third will be parabolic, and fourth will be first will be unit impulse, ramp, unit step, and then parabolic. So let's take it one by one. So first of all, we are considering unit impulse. So when we are considering the unit impulse, we are calling it impulse response. Response when the input is impulse. So we call it impulse response. Impulse corresponds. Then consider unit impulse signal. So that for that unit impulse signal, del t, rs is of course we know 1, so rt is equals to del t. So at the place of rs we can very well substitute as 1. So now substituting rs as 1, we have cs is equals to 1 upon st plus 1 into 1. So this is the reduced output response. Next, we have to convert it into time domain. Then what we are doing, we will just take t common, considering the t as common, s plus 1 upon t, and then we have this overall as a substitute in time domain. We can write it as e raised to the power. So this term goes with the coefficient of t in exponential power. So it is e raised to the power minus t by t ut, and 1 by t comes as a constant. So it is output response is ct is 1 by t e raised to the power minus t by t into ut. So this is the overall, we call it impulse response. So of course we can have a graphical representation. Of course, here is the graphical representation, here is t, and here we have, let's redraw it. For this we can draw a graph, and then for this we can draw a graph. Let's take about, and I'm not able to draw here, let's draw here. Let's take t here, and here we have response ct. So since it is e raised to the power minus t, it is exponentially decaying function like this, and this intercept has to be 1 by t. We can see in this diagram, the unit impulse response is shown in following figure. The unit impulse response ct is an exponentially decaying signal for positive values of t, and it is 0 for negative values of t. Now we consider the same for step input, what we are going to do? So for this RS, we will now consider step input. So of course, for step input, this RT will be equal to UT. So of course, for UT, we have RS as 1 by S. Now we will pick up the same output expression. At the place of RS, instead of writing 1 for unit impulse, we will write 1 by S for unit ramp. Now, to see this, we are very much clear that we can obtain CT from CS by using a method of partial fraction. So, finding out the values of A and B using partial fractions, we have to just find out the coefficients, and these values of A and B will be according to this equation. CT will be equal to 1 by S minus T by T into S plus 1 by T. So here we can see that this T cancels out. This 1 by S is 1, and then 1 upon S plus 1 by T, as similar in the previous case, it is e raised to the power minus T by T. So here we can see that this is what we call overall output, and from here as well we can see that we have to find out the overall output, and the output here can be redrawn. Now, steady state output, that is, steady state means when the system has attained the settlement, when the system is having no change, when the system is showing no change with respect to time. So we can very well see that this is a constant, a steady state. Of course, this will come as CSS. Since this varies with time, so this will be of course a part of transient. So that too, that is coming with minus of e raised to the power minus T by T. So of course, transient will be like this, and then after that transient phase is achieved, it will be settled like this. So we have to see, this distance is, this part is C transient, and then ahead of this is C steady state. The value of unit step response CT is 0 at t equals to 0, and also for all negative values of t. And in addition to this, it is gradually increasing from 0 value to finally it reaches this state of unit UT, and so the steady state value depends on magnitude of the input. Now, considering the same first order system for ramp input. Now, ramp input means RT will be equal to T. When RT will be equal to T, RS becomes 1 by S square. So, when RS becomes 1 by S square, in the same standard output equation, we will substitute the value of RS as 1 by S square. So, for 1 by S square, we see it will be 1 upon S square into ST plus 1. Following a method of partial fraction, we split it into A, B and C. Now, getting these values of A, B and C, we can rewrite this into this equation. See, the overall output is 1 by S square, A coming out to be 1. Now, B is equal to T, like minus T, so it is minus T by S, plus C comes out to be T, then it will be T upon S plus 1 by T. Now, substituting this into time domain, we have 1 by S square as T, 1 by S as 1, that T as a constant, capital T is constant, it is coming just like that. And now here, this itself is e raised to the power minus T by T. So, this T, of course, this T is constant everywhere. I think I don't need to tell you what is this t. Starting from the very first diagram, this is this t. Let's say 1 upon s into 2 or 1 upon 2s. So this is capital T here, constant. Now, of course, the term which is varying with respect to time will be accounted for transient term. So it is e raised to the power minus t by t, and then the term which is unit ramp, and here we will get t minus t ut. So this term will give us e raised to the power minus t. Let's say I'm drawing the input with the help of blue color. This is RT equals to T, and then output with red color. Output is this. So this is this portion, e raised to the power minus t by t, and then again let's say for t is equals to 4, it is 4 minus t. For t equals to 10, it is 10 minus t. For t equals to 50, it is 50 minus t. So everywhere it will be like this, where this distance will be nothing but capital T, but it is following the output. So this is CT with maroon, and blue is RT. We can see here, this one is input and this one is output. We can see that output is following input, but there is some delay terminology going on. The unit ramp response CT follows unit ramp input signal for all positive values of t, but there is a deviation of t units from the input signal. So everywhere this distance is constant, and that is t. It is t. So this was first order system subjected to impulse input, unit input and ramp input. Now we are considering the first order system is now subjected to parabolic. Now here parabolic input means RT will be equals to t square by 2. When we talk about t square by 2, RS becomes 1 by S3. So this conversion t square by 2 to 1 by S3, it is very much easier. Let's consider it t square, then we will not get it 1 by S3. So to make this conversion easier, we took it t square by 2. Now CS will be the same standard equation, 1 upon ST plus 1 into 1 by S cube. Then we will split into partial fraction, and after splitting into partial fraction we will get the overall output as this. Now overall output as this, 1 by S cube will give me this term, then 1 by S square will give me this term, t square by 2 will give me this term, and then of course this will give me the term with exponential function. Now we needless to say that this gives me the transient behavior, whereas this gives me the steady state behavior. So this was the response of first order system for unit impulse, step, ramp and parabolic. Now ahead of this we will move on to second order system. In the second order system we have to study the new variations, and we have to study the impact of the different parameters. For example, damping ratio, we have to study the impact of several factors, which is nothing but damping ratio and resonance frequency. See, resonance frequency, damping ratio, everything comes into the picture when we talk about second order system. Of course, the second order system will be subjected to all the 4 inputs again: impulse, unit ramp, parabolic. Now, when we talk about subject of second order transfer function, second order system, we will also consider the impact of damping on this. We will also consider the impact of resonant frequency on this. We will also consider the output as a result of different values of damping. Like damping would range from 0 to 1. Now, what is damping actually? Let's talk about an output CT, different kinds of output. So if CT, the output is just like this, it is sustained. So there is no damping here. If I draw another response and I draw it like this, so if I draw the envelope, it's like this. We can see certain amount of damping here. Again, let's draw another diagram. And suddenly it goes out of the board. It's like this. So we have to study what is damping. So here is damping ratio. Omega R is resonant frequency. Omega D will be damped frequency. Accordingly, we will have damped oscillations. So we will study everything when it comes to second order system. From my next lecture, we will study and start second order system subjected to all the 4 kinds of inputs, that is impulse, step, ramp and parabolic. So as of now, that's all from my side for lecture 2 of unit 3. Thank you.